remember how you might go about solving this equation. So I've got 4 and then in parentheses x plus 3, that's squared, minus 12 equals 388. If you're working on this equation, what would you do first? Add the 12. Perfect. All right, let's add the 12. All right, so I've got 4 times x plus 3 squared equals 400. What do you want to do next? All right, so then I'm going to get, let's see, x plus 3 squared equals 100. All right, then what do we want to do? Good. Don't FOIL this. Okay, this is going to be ideal. If you can have the little set of parentheses squared equal to something by itself, just take the square root. Then you don't have to FOIL, and we're just going to have to take the square root of 100. All right, so I'm going to write x plus 3 equals what? What do you think? Yeah, don't forget, if we introduce that square root, you got plus and minus. So there's 2 answers to that. It could be 10 or it could be negative 10. All right, now I'm going to do one more thing. I'm going to subtract, well, I'm going to do 2 more things actually. I'm going to subtract 3 to get it away from the x. Now, I had a couple of people do this on the quiz, right? This would be negative 3 plus or minus 10. If you leave that like that, I can't give you full credit for that because that can be simplified. If that was like 10 radical 2, you're done. Or if that was 10i, you're done. But if it's just 10, you can do negative 3 plus 10, bless you, that would be 7. And you can do negative 3 minus 10, that would be negative 13. So you can get 2 answers if that's a plain number when you take the square root. If it's a radical, you're done. If it's got an I, you're done. But if it's just 10, don't forget you can continue to simplify that and tell me those 2 answers, which would be 7 and negative 13. Is anybody having a question? Okay, so our goal today is we're going to have equations that look like this, a set of parentheses squared equal to some number, and we're going to solve them by using square roots. But we might have to create that situation, so I'm just going to give you a little example here. And I'm not going to tell you what this means at the moment. We're going to talk about that in a second. But it says I have standard form, x squared plus 10x plus 25. I have another example here, x squared minus 14x plus 49. These are both examples of what we would call a perfect square trinomial. All right, so this is one, and this is one. Could anybody tell me, like, if I asked you to factor this, tell me 2 numbers that multiply to give you 25, add to give you 10? 5. This would be x plus 5 and x plus 5. Now, how can I write that if they're both the same? Excellent. Okay, and this is what we want, because if we can create that in an equation today, then we can just take a square root and get rid of it. What about if I asked you, like, could you factor x squared minus 14x plus 49? So, like, multiply to get 49, but add the negative 14. What would the 2 factors be there? Both of them are negative. So it'd be like x minus 7, factored form. Because they're exactly the same, we can just squish them together and write it as x minus 7 squared. So if I asked you to tell me, like, what's the definition of a perfect square trinomial, what do you think it means? Bless you. If you had to look at those 2, like, what do they have in common? Say that again? C is a perfect square. That will always happen. That's true. Only requirement here, C will be a perfect square. Perfect square trinomial means both factors are the same. That's all the requirement is. C is going to be a perfect square. She's right every single time. But the actual definition is going to say that both factors are the same. That perfect square gets created because you do, like in that case, you do 5 times 5, 25. Negative 7 times negative 7 is 49. Okay, the other thing I want you to notice here, and this is always the case, this C value, and I know there's only 2 examples here, but the C value is always positive. It's the B value can be negative or positive, but the C value will always be positive. So what we're going to do is, if we don't have a perfect square trinomial, we're going to create them in some of the questions that we're going to work on today. So here's how you do this. It has to be in this format: x squared plus bx plus c equals 0 is what I'm going to write down. The a value, if you're going to do the process we're going to work on today, has to be 1. It cannot have a number in front of it. I am not going to give you any problems today that have a number in front of the x squared. We'll actually work on that a little bit more tomorrow. So all the questions should be of this format today. So if that's the case, here's how you do this. The c value, your constant, right? That's my constant plain number, has to be equal to the b value divided by 2 squared. I call that the magic number that we're going to add to both sides of the equation when we actually seem to work with this. But the plain number has to be the b value divided by 2 squared. I'm just going to back up and show you this real quick. So on this question, like, my b value is 10 divided by 2 squared. That would be 5 squared, which you guys can see the constant term there is 25. If I did this one, my b value, negative 14 divided by 2 squared, it's negative 7 squared, but anytime I square something, it becomes positive. So negative 7 times negative 7 is positive 49. And you guys hopefully can see those constant terms match up with that little formula. It's the b value divided by 2 squared. So all we're going to do in this first example is just find that number that would make what I've got set up here into a perfect square trinomial. So all you got to do, you're going to grab the b value, which, like for this one, it'd be 20. You're just going to divide it by 2 and square it. So 20 divided by 2 is 10. I'm going to square it. So I'm going to get 100. So what I would do to what we call complete the square is put 100 right here. If that's the case, then the two factors will both be the same. Does anybody know two numbers multiply to give you 100, add to give you 20? 10 and 10. All right, so the factored form here, this would be x plus 10 squared. Now, here's what I want to point out to you, because some of these can get tricky, and I'm not going to lie, some of them have fractions in them. Whatever you square, like we squared 10, that is what's in the factor with the x. Those will always match. Whatever you square, that's going to be your factor. So like on this one, I'm going to do negative 8 divided by 2 squared. That would be negative 4 squared, which is going to be positive 16. Whatever we get is always going to be a positive value because we're going to square it. And I swear to you, whatever you square, so I squared negative 4. So my factor would be x minus 4 squared. And that would be true. Multiply to get 16, add to get negative 8, negative 4, and negative 4. That, whatever I square, matches the factor. And you're probably like, duh, Miss Grody, I could have figured that out. Okay, now, here's the question where this is going to be useful to you. If the b value is not an even number, like every question I've done here, the b value has been an even number. So I had 28, up here we had 10 and 14. If it's an odd number, my b value here is 3. So it follows the same process. So it's the b value divided by 2 squared. However, unlike all the other questions we've done so far, I can't actually divide negative 3 by 2. That's it's a fraction that can't be reduced any further. I can't square it though. If I square that, I'm going to square the top and the bottom. So negative 3 squared would put a positive 9 on the top. 2 squared would put a 4 on the bottom. And I know this looks super weird, but that's how I would add and create a perfect square trinomial. I would add 9 over 4. Now, this is where what I told you is going to be really important. Whatever you square, I swear to you, will be in the factor. So the factored form of this, it would be x minus 3 over 2 squared. Whatever you square, that's going to be the factor. If you wanted to FOIL that out to check, that middle term would become negative 3. And if I do negative 3 over 2 times negative 3 over 2, it would give me back the 9 over 4. But if you're working with the fraction, if you can remember, whatever you squared, that's going to go in your factor. That should be helpful to you on a lot of these questions. Okay, I'm going to do one more, and then we're going to actually solve some equations here on the back. So this is a little example that is missing the b value. And I used a k in the problem to represent that. So remember, I told you guys the constant term has to be equal to the b value divided by 2 squared. So if I use that little definition that I gave you to find the plain number, I'm going to work backwards here and find the linear term. So for this question, I know the constant is 25, and so that should be, they use the letter k in this example, and I think I used the letter k in this example because it's really similar to the question on the Math Excel, so I was trying to make it look like that. But if I can solve that little equation, then I can get my value to make that a perfect square trinomial. So again, we're just going to take square root. Real quick, I introduced the square root. So this would be plus or minus 5, and then we'd have k over 2. Now, I know I have a plus and minus symbol. You can still get k by itself by multiplying by 2. You would still have the plus and minus symbol, but there's 2 possible values that you could plug in there to make that a perfect square trinomial. It could be positive 10, or it could be negative 10. When you get to the Math Excel, it might say to you, what's the positive version or what's the negative version? But there are 2 possible answers. That could be a 10 or a negative 10. Both situations would be a perfect square trinomial. If it was positive 10, it'd be x plus 5 squared. If it was negative 10, it'd be x minus 5 squared. So really similar. This question gives you 121 as the constant. So that has to be my b value, which is represented with the k here, divided by 2 squared. So I'm just going to do exactly the same thing. Take a little square root. I introduced the square root, so I got that plus and minus. Perfect square, this is 11. K over 2. And then even though it has a plus and minus sign, you just go ahead and multiply it by 2 and keep the plus minus sign. So this could be 22 or negative 22. Both of those numbers would work plugged into that to make that a perfect square trinomial. Is anybody having a question? Okay, now, we're actually going to do some problems with this on the back. I have the process kind of explained at the top of the page here, so if you want to go back and read through this, that is completely fine. The one thing that you're not going to see today that's going to be a problem, the first thing is the a value has to be 1. You don't have anything other than that in any of the questions today. All right, now, here's what you want to do. You want to have the term with the x squared and the term with the x on the same side. Anything else, you want to move it to the other side. So for this question, any plain number, I'm going to move to the other side of the equation. I know that's a little different from what we've been working on because we want to set these equal to 0 for most types of solving quadratics, but in the case of completing the square, I'm going to try to create a perfect square trinomial. So I need the linear term, the quadratic term. Here's how I'm going to write this. I'm going to write plus, and I'm going to leave a little space to complete the square. I'm going to move that 15 to the other side. Now, because I'm working with an equation, I'm also going to put plus a little space on the other side, because if I add something to one side, which I'm going to do on the left to complete the square, I have to keep my equation balanced, so we got to add that to the other side as well. So I'm just going to find a little magic number to make this a perfect square trinomial. So you're going to grab your b value, which is negative 6, divided by 2 squared, which is, bless you, negative 3 squared, which is positive 9. That value should always be positive because you're going to square something to get it. All right, so there's my magic number. I'm going to add 9. On the left side, that creates a perfect square trinomial. On the right side, that balances the equation. That keeps me with having a situation where I added 9 to both sides, so it keeps my equation balanced. Now, this guy, I'm going to write this out on this question in 2 steps. This would be factors of positive 9 that add up to negative 6, x minus 3 times x minus 3. The entire purpose of that is that those 2 factors, if you have a perfect square trinomial, are identical. So then we can squish them together, and this other side's just 24. Now, that is what I want because I can get rid of it by taking a square root. And this is going to bring back some of the different skills we've been working on the last couple of days. In this case, I'm going to have to break down the radical here. So if you like a factor tree, please use a factor tree. I like to try and figure out the biggest perfect square. Into 24, biggest perfect square is just 4. So I'm going to rewrite that real quick as 4 times 6. And what I'm going to be able to do is take the square root of 4 out in front of that radical. So I'll have a little 2 out in front there. So I'm going to have x minus 3 equals plus or minus 2 roots of 6. And to get x totally alone, I do have to move the 3. So I'm going to add that to the other side. And in this case, I'm not going to be able to simplify this any further than 3 plus or minus 2 roots of 6. You can't go farther than that because that 2 radical 6 is not a like term with the 3. So you have to leave them just as 2 separate pieces. It's 2 answers though. That plus and minus symbol is just a little shorthand way of doing that. Okay, now this one's a little bit more annoying because I got to move some stuff around a little bit more. You want your squared term to be positive just like you do with your factoring, but you want the squared term and the term with the x. So the quadratic term and the linear term on the same side. If you got any plain numbers, just move it to the other side of the equation. For this problem, what I'm going to do, I'm going to add 16x to both sides, and then I'm actually going to subtract the 89 to the other side. So I'm going to write x squared plus 16x. Then I'm going to leave myself a little space so I can complete the square. Make my perfect square trinomial. The other side would be negative 89 plus, I'm just going to write that little space for myself because when I complete the square, I got to add that number to both sides to keep my equation balanced. So you're going to grab your b value, which now when I set that up is positive 16, divide that by 2 squared. So that's going to be 8 squared, which is 64. So I'm going to add 64. Left side completes the square. Right side keeps my lovely equation balanced. Okay, so multiply to get 64, add to get 16, 8 and 8. It's whatever you square. I swear to you, whatever you square, that's the factor. So this is x plus 8 squared. The other side, we're just adding numbers together. Negative 89 and 64 is negative 25. So we just like this format because then we can get rid of the parentheses by taking the square root. What would you tell me the square root of negative 25 is? Yes. So this is what we did yesterday with the I. So just put plus or minus 5i because we introduced the square root. The only other thing I'm going to do is I'm going to move that 8. And we won't be able to simplify this any further. We're just going to have x equals negative 8 plus or minus 5i. And those are, I know that is crazy looking, but those are our 2 answers. If we actually went and plugged that in for x, that would make that equation true. If you wanted to try that out with that I button on your calculator, you could check that out to check your answer. Is anybody having a question? Okay, now, these ones at the bottom, these ones are a little bit harder because the linear term or the b value is going to be an odd number, but the process is exactly the same. So I'm going to take this first equation and I'm going to keep the linear term and the quadratic term on the same side. So I have x squared minus 9x. I'm going to put plus a little space for myself to complete the square, and then I'm going to move that 6 by subtracting it, and then again I'm going to leave a little space to complete the square on the other side. So I'm not going to lie to you, if you have an odd b value, you're going to work with fractions. So you might want to, if you don't have your calculator out, you might grab it because I'm going to use it on these 2 questions at the bottom here. So I'm going to take my b value, which is negative 9, divided by 2, and square that. I can't actually divide negative 9 by 2, it doesn't reduce. So we're just going to square. The top would become positive 81, the bottom would become 4. And leave this as a fraction. Do not write this in here as a decimal. I promise I'll show you why. It'll make it easier to work with as a fraction. So I'm just going to add 81 over 4 to both sides. So this is where I told you at the beginning, I swear to you, whatever you square, that is going to be your factor. So multiply to get 81 over 4, add to get negative 9 is going to be this minus 9 over 2. So I'm going to write x minus 9 over 2. If your b value is negative in the original problem, the factor it should also be negative. If the b value is positive, we'll see that on the next question, then that will be a positive in there. This is where I'm going to grab my calculator. So I'm just going to use my favorite button. All right, we're going to do negative 6, and then I'm going to be on the screen so you can actually see it. I'm just going to put parentheses around this. So plus 81 over 4. And I'm going to hit equals. And I could probably convert that, but I'm lazy. So I'm going to hit math, which is the 4th button down here, and just hit enter twice, and that'll give it to you as a fraction in lowest terms. And you want it as a fraction, which you're going to see in a second. So I'm going to get 57 over 4. Okay, now here's the reason why you want to leave this as a fraction. If you have done this correctly, every single time, the number on the bottom of this should be 4. Can I take the square root of 4? Yes. Okay, that's why you want to leave this as a fraction. So I'm going to have x minus 9 over 2 plus or minus. The bottom of that will be 2, because this is the square root of 4. Now, if you can break down the radical, you're welcome to do that, but 57 does not break down under a square root, so I would just leave that as the square root of 57. I can also add 9 over 2 to the other side, and if you guys notice, I have 9 over 2 plus or minus the square root of 57 over 2. You can leave it like this, or the reason I had you also leave it as fractions, this has a common denominator. Both of the denominators are 2, so probably a more typical way you might see this written, you would actually have 9 plus or minus radical 57. All that would be on the top, and then the whole thing would be over 2. And I know we haven't done it yet. We're going to work on this later in the week, but we're going to do quadratic formula. A lot of times the answers end up looking something like that when you're done with it. This is just another method for getting that type of an answer. And you should just leave them as fractions because those will be a common denominator. That'll always be a 4 on the bottom if you're completing the square, and you'll always be able to add them together. Okay, let me try to go through one more with you. I don't have to do anything to set this up because I've already got the squared term and the linear term on the same side. I am just going to leave a little space after the 7x to complete the square. So again, the b value is odd here, so this is a little tricky. You're going to do 7 over 2 squared. That does not reduce, so you're just going to go ahead and square that. 7 squared is 49, 2 squared is 4, so what I'm going to add to both sides is 49 over 4. Alright, now, I swear to you, whatever you square, that's going in the factor with the x, so I squared 7 over 2. So the factored form of this should be x plus, right, if the b value is a positive, the factor should also be positive, 7 over 2 squared. On the other side, we actually have to add that 49 over 4 to the negative 16. So I'm just using my calculator to do negative 16 plus 49 over 4. Hit enter, and then just go, I know you can convert this, but I'm just being lazy. Hit math, and then hit enter twice, and it'll make it a fraction for you. In lowest terms, so this is negative 15 over 4. Once you're here, we're just going to take a square root. We want those parentheses because we can just cancel them out all at once by taking a square root. You're going to get x plus 7 over 2 equals. Now, I'm going to put the plus and minus, right? And I know the square root of 4 is 2. What would you put on the top of that fraction? How could I write the square root of negative 15? Heck yeah. Just put an I. And then 15 doesn't break down under a square root, but you want to put the I in front to take care of the negative. Now, I'm going to do the same thing I did on the last question. We're just going to move the 7 over 2. It's positive, so I'm going to subtract it to the other side. So I would have x equals negative 7 over 2 plus or minus I radical 15 all over 2. If you want to leave it like that, that's okay, but you can actually simplify that just a little bit. You have a common denominator, so you could put the negative 7 plus or minus I radical 15 the whole thing over 2. Both of those are correct. And that's 2 answers. Remember that. If you have a plus and minus symbol, it's just a shorthand way of writing 2 answers at the same time. Is anybody having a question?